All right, so we're going to get back to work on the Hercules IXB3 for Junkyard Dave here on YouTube. Basically, he wanted us to do all of the machine work on it, put some hard seats in it, put new valve guides and so on. We're also going to bore it 20 thousandths oversize. Crankshaft needs ground. We're going to do all the surfacing. And he also had, I think he told me he took it to a machine shop and had him drill out the broken bolts because there were 2 broken bolts, and honestly, whoever he took it to did not even finish getting the bolt out of that one. There's still a piece of the bolt in there. What happens when you drill on, you don't get perfectly centered on that bolt and you have a hard bolt next to cast iron, your drill starts to wander into the cast iron, and that's what he did here. So we're going to have to go through a little bit more complicated repairs on those 2 than I would like to have to do, but it's what you do. This thing was cast February 17th of 48, so pretty old here. It's going in a super rare car that he's doing a restoration on his channel, so be sure to go check it out. Right now I'm going through and actually pulling the old valve guides and drawing in the new valve guides as well. So went through and did one just to see how things go and get my process down. I'm not pulling them all the way through yet because the nut that I'm using is too big of diameter to go through the guide bore there. But I got to break them loose and get them close enough. And then I use this old valve guide from something. I'm not sure exactly what it's for. It'll go through the guide bore, so then I use it as a spacer, but there's not enough room to start with it there. So this is just one of those punch knockout kits from Harbor Freight, Pittsburgh. Hydraulic punch driver kit, it calls it. So it's just got this cylinder here to pull with, and then we basically adapted a bolt that we can use that has the threads on this side as well as the internal threads for, that's 5/16 all thread, and we can go through the guide like that. So I've got them all pulled nearly up through. Now I can go with the guide that fits through the bore by itself as a spacer and pull them on the rest of the way through. And as for the reason I'm not driving them, we don't like driving them through from the combustion side. Where's that old one? Because they have all this corrosion built up, and it'll actually kind of broach the bore as you go down through when you go that way. Not always, but it can happen. It's also super thin on the top side there. It's pretty thin on the bottom side too, but you'll see it's turned down there on the end. It's actually a smaller diameter. So we could drive from the bottom side here, but I know they're pretty stuck because they've been in there a long time. And I don't know, the hydraulic just works. It takes a little bit longer, but it's a really smooth process. I have a good feel for if we're messing anything up or not. It's also, I'm not having to try and get a driver that's long enough to actually drive from down underneath in the crankcase, basically. So it just kind of works better, and it's easy enough. So there we have it. I don't know if much shows very good, but all the guides are out. The bores look good, nothing damaged. Again, that's the guide that I already installed. So now we're going to go through, clean up the bores real quick, get some press fit lube in them, and pull the new guides in. If it wasn't so thin, I'd just drive them in from the top here and it'd be fine, but they're just so thin I don't want to risk cracking one. I'd rather do it the longer way, but safer way. After getting all of the valve guides taken care of, I figured we'd better start by tackling the thread repair on the 2 botched broken bolt removals from the previous guy. From the looks of it, rather than actually getting the broken bolt removed, he simply drilled down through it, off center I might add, and then ran a tap through it, which obviously isn't right. After an attempt at simply chiseling the remaining bolt material out, I decided to put the carbide burr in the machine and see if we could slowly thin out the bolt until we saw the parent material of the cast iron. In an ideal scenario, you can get the bolt thin enough that the remaining threads just kind of peel out, and in this case, we're going to be installing solid thread repair inserts, but we still want to get the hard bolt material out before we drill so that the drill doesn't wander. With the holes having been drilled off center previously, we figured a good method to drill in the proper position for our thread inserts would actually be to bolt the cylinder head onto the block and use it as a guide for our drill. We found a drill bit that matched the through hole in the head and floated the table to center up on the drill before switching over to the proper size drill for our time cert. The head bolt holes are already drilled through into the water jacket, so we don't have to worry about hitting a specific depth. While the head was bolted on, we repeated the process on the second damaged hole. While the second hole cleaned up at the drill size for a time cert, the first hole was still super oblong with remaining threads, so the cylinder head went back on to center up the machine before removing the head and getting out the big boy drill for a big cert. Looks like that cleaned it up, so now we can move on to the remaining steps to install the time cert in the second hole. First, the counterbore is cut at the top before the threads are tapped for the OD threads of the insert. We put a little Loctite on the insert to make us feel good, and then use the installation tool to thread the insert into place. In hindsight, I wouldn't have cut the counterbore as deep so that the insert would be closer to flush, but I just followed the instructions for the tool. We repeated the process with the big cert tools on the other hole, but we did cut the counterbore a little bit shy of full depth on that one. With that, we did a quick alignment check on all of the head bolt holes, and everything looks great, so we can move on with our machine work. To start with, the cleaning guy worked at getting the cylinder head up on the RMC boring and surfacing mill for a quick cut. Flatheads can sometimes be difficult to fixture, but with a couple of studs through the spark plug holes and a bit of shimming to get the head true, it was ready to cut. You can never really expect to get a perfect first cut on something of this vintage, both for the fact that you have no idea what the history of the engine has been as far as maintenance, but also because the machining simply wasn't as accurate back in the day when this was made. In this case, it did cut a bit wonky, but we'll go ahead and make a couple more cuts to make it flat. Before we can move on to installing hard exhaust seats, we measured the valve stems of the new valves and checked the clearance on our new valve guides. As installed, they were already sitting pretty close to 3 thou clearance, which is probably a good spot on something like this, so we'll simply touch hone them with the diamond valve guide hone to take down any high spots or burrs. With our valve guides honed, the block was set up on our Surdy 4.5 valve seat machine, and a seat counterbore cutter was selected to cut the counterbores for our hard exhaust seat inserts. After touching off the cutter on the deck of the block and zeroing the DRO, one of our valve seats was used to set the depth stop on the spindle so that we don't cut the counterbore too deep. While it's not necessary to use coolant when machining cast iron, I find that it does sometimes help aid in cutting counterbores. There are times where we would also install intake seat inserts, but intake seats don't need to be as hard as exhaust seats that see far more heat, and the design of the block would have left nothing to support the bottom side of the seat, so we opted against it. With the counterbores cut, the exhaust seats were driven into place, at which point we moved the block back over to the boring and surfacing mill to get leveled up so that we could cut the deck surface and bore the cylinders. Both of the thread repair inserts come fairly close to the head gasket sealing surfaces, so we'll surface enough to make them flush with the deck, as well as clean up any rust pitting or imperfections. There was also a funny low spot on one end of the deck, which looks like someone somewhere along the way set the cutter a little bit deeper than they intended to, but caught the machine just in time. If you go back to my channel and look for a video on a Farmall H, you'll probably see something similar. We've sourced 20 thousandths oversized pistons and rings for this engine, so the next step in the process is to get a cutter set up to rough bore it within about 4 thousandths of our finished bore size. The machine has a built-in centering finger, which allows us to indicate on each bore before the boring process. After the cylinder is bored, we use a different cutter to put a small chamfer at the top of the cylinder to aid in safe piston ring installation later on. With machining on the boring and surfacing mill finished, we'll move back over to the 34.5 to finish our valve seats. The goal is for the end result to be fairly similar to what this engine would have looked like when it left the factory in 1948. So we'll start with opening up the ID of the new exhaust seats to blend into the throat of the exhaust port. From the factory, this type of engine would have basically been 3 angles: 90 degrees into the throat, a 30-degree seating angle, and a flat top angle into the deck surface. As such, we're going to do something very similar. A 60 thousandths wide 30-degree cutter was set up for the intake seat and adjusted such that when finished we will see a sliver of bottom angle and a sliver of top angle, showing us that we just have our full seat width. With a bit of color on the valve, we can see that the seat contacts the valve face right in the center how we want it. We're going to repeat the same process on the exhaust seats, however with a slightly wider 80 thousandths wide 3-angle cutter. With our valve seat machining finished, the last step on machining the engine block is to finish hone the cylinders in our Sun & CV616 cylinder hone. In this case, I used 3 separate stones, starting with a very coarse grit diamond to remove material quickly, getting us close to the final size, followed by a slightly less coarse vitrified stone, and finally plateau finish to our final bore size with a much smoother vitrified abrasive. The piston rings in this application are very forgiving in terms of cylinder wall surface finish, but even so, when checked with the profilometer, we had readings in a great range on our core roughness RK, our peaks the RPK, and our valleys the RVK. The cleaning guy got to work grinding the crankshaft, which is probably one of the most intricate operations performed in our machine shop. The chucks of the machine have been offset by half the stroke length of the crankshaft so that the rod journal spins on center and can be ground. An Arnold in-process grinding gauge is used to keep an eye on the diameter of the journal as the grinding occurs, and this feed button moves the grinding wheel into the workpiece in 0.2 of 1/1000th of an inch increments. A steady rest is also used and constantly being adjusted with a friction feel to keep steady pressure on the journal. The cleaning guy also gave us his best effort to set the camera up and record grinding the main journals and polishing the crankshaft, but he accidentally recorded in slow motion, so enjoy this flickery slow motion aesthetic. All of the connecting rods were reconditioned as well, which is done by first grinding the mating surface of each connecting rod and each connecting rod cap. After the caps have been ground, the sharp inner edge is lightly chamfered by hand to prevent peeling up material from the back of the bearing later on. Next, the caps are all mated to the correct rod, and the bolts are installed and nuts torqued to the proper specification. At that point, the bore of the connecting rod will be smaller than the factory diameter, and they can be honed back out to the factory specification. Typically, a coarse honing stone is used to remove material quickly and get you close to your finished size, before a smoother stone is used to get you within the proper size tolerance. After the connecting rods have been resized, they're checked against our Sun & rod straightening fixture, and in this case the feeler gauge was even on all sides, indicating that the rods were all straight and free of twist. We decided to go ahead and balance the rotating assembly for this engine, so all of the pistons and connecting rods were weighed and weight matched. In the case of the rods, the big end is weighed individually, and slight amounts of material are removed with the belt sander to match the weights. The overall weight is also checked, and in this case we came in within about a gram of each other. The crankshaft is then set up and spun on our Sunnin DCB750 balancing machine, and in this case it was actually already fairly close.
Okay, there it wants weight and moved up here.
Kind of see the thing right here. We'll gradually go ahead and add the additional components like the front pulley and the flywheel and make adjustments as needed. The machine gives us the option of either removing weight or adding weight, and the decision made depends on where and how much adjustment is needed. Before making any adjustments, we sometimes like to use a bit of clay to simulate the changes that we're about to make and verify that they will change the balance in the way we expect them to.
I'll try again. It flung this weight off the last time I spun it. So we'll start it spinning. Weight stayed on that time. And there we are, 0, 0. This will be our final spin on this crankshaft assembly. We have one small hole here that we drilled to bring the flywheel in. We have a small, actually I used a woodruff key, welded it on down here, got something that was about the right weight onto the front pulley to bring it into balance. And then after that was all done, I put the pressure plate on and added another piece of metal back here, welded onto the side of the pressure plate there, that should bring this all in real close. Let's make our last spin here and see what happens. There's ramping up. Should bring that up somewhere around 750 RPM. Yeah, 735. It's measuring. And there we have it. We are within 1 gram left, 1 gram on the right. I'm going to call that a wrap. I don't think we can get it much closer than that.
To make sure Junkyard Dave doesn't have any issues with this engine going back together, we test fit the crankshaft and set the crank end play, and we also had the camshaft and tappets sent out to Delta Camshaft in Tacoma, Washington to be re-ground, and they came back looking great. Having decked close to 15 thousandths off the top of the block, we verified that everything looked good in the valve train and everything checked out. Finally, we test fit a piston and rod assembly and found that the piston actually protruded about 10 thousandths outside the deck. After discussing with Dave, we decided that it would be fine and not to fly cut the pistons, as there is no issue with clearance due to the head gasket thickness, and if anything, all it will do is help with the low compression. While the Hercules IXB3 was used in far more applications than just the 1948 Keller Super Chief, it was still a ton of fun taking this small piece of niche automotive history and making it brand new again. Junkyard Dave has a massive project ahead of him restoring this rare car, and we definitely want to wish him luck. So be sure to go to his channel and check out the project. Thanks for sticking around to the end of this video. Be sure to like and subscribe, and we wanted to wish everyone a happy new year and thank you for a great 2023. Just for fun, here's a few clips of that Alice Chalmers 210 that we did a video series on around this time last year. And I don't know, who thinks the cleaning guy ought to have his own farming YouTube channel? Just a thought.